In this section, we were tasked with synthesizing the waveform shown here on the right, consisting of two sine waves, 180 degrees of each sine wave. The first with amplitude of 3 volts, second with amplitude of 1.5 volts, both duration of 560 microseconds each, with a total duration of 1,120 microseconds for the period. To achieve this, we use the knowledge we gained from previous lab that at a 2 megahertz clock cycle shown here, that the port function takes approximately 3.94 or 4 microseconds to perform its task. We took the 560 microsecond duration of each of the sections of our synthesized sine wave. We divided that by 2 to give us our 90 degrees to take advantage of the fact that sine waves are mirror images of each other. So we can take the first 90 degrees and then just mirror those values to give us our 90 to 180 degree to reduce the number of points we actually need to plot. We can always do it without it. This was just to save a little bit of time. We took 560 microseconds, divided that by 2 to give us our 90 degrees. Then we divided that 280 by 3.94 microseconds, which is the command time, the total command time, to give us a total number of points required for the 90 degrees each of 71.06, rounding down to 71 commands, which is all of our port commands. We have 71 total here. What we did was we utilized the equation of our maximum amplitude times our sine function of our value that we're looking for, x, over the number of points required, so 71, and then multiply that number by 90 because we're using the 90 degrees to give us our final values, which is what you see here on our port functions. We are taking these analog values and running it through our digital analog converter here. It takes advantage of the R2R ladder system coming out of our microcontroller into the digital analog converter. It comes out through our output, and we're measuring it with the oscilloscope. Here you can see that we are achieving the waveform that we're required with the first waveform amplitude of 3 volts, the second section of 1.5 volts. Total duration here, our period, is 1.124. It fluctuates here, just the clock cycle on the microcontroller. Also a little bit of error here in the cables, not that bad. Each period, or each duration of the sine wave is 560 microseconds. We can adjust to the second waveform here. Put it right on the peaks there. As you can see, 560 microseconds. Here we show our code. After initializing each of the inputs on the C port as digital as well as outputs, and then we selected our clock cycle here to 2 megahertz. Inside the while loop, we hard-coded each port value, which is a little under 300 points of hard coding. This we achieved using Excel to kind of speed up the process. Helped us immensely in organizing all of our values and everything, so we can cut and paste into our compiler. But we were able to do it. We got our sine wave, or our waveform function that was requested of us with the duration of each waveform and the period as well as voltage amplitudes of each